Hi, the purpose of this video is to teach you how to do the trend projection model in Chapter 4. I'm going to teach it to you two ways. First thing I'm going to do is teach it to you by hand. And then the second thing I'm going to do is teach it to you using Excel, both of which you are welcome to use. Just remember that if you do choose to do it on Excel, you're going to want to make sure you rewrite the numbers down onto your handout, as you would not be able to use any Excel handouts or anything calculated in Excel and printed on the test. So let's just get started here. This data you're going to probably recognize from the other problems. Nonetheless, the first thing we want to do is identify the relevant variables. So when we do this, it's slightly different than the previous model, because here time is denoted by X. So you'll notice right here, X is the time. So remember, in the previous problems we talked about, period 1, 2, 3, 4. Well, we've got the same thing here. It's just that in the case here, we're labeling that as X, and that becomes relevant in a little while. And then actual demand, before we were calling it A, but now we're calling it Y. So ostensibly what we're saying is that time is predicting the forecast amount that we are interested in. So let's think about that for a minute. It means that time, as time progresses, as we move along the x-axis like this, we are predicting what's on the y-axis, and in this case it's the forecast. So if we see a trend over time where our demand for our product is increasing, then we would see a line sort of like this. If on the other hand we're in a sort of declining market, of course we would see the opposite, right? We would start high and go low, because this is time down here, and as time marches on we see the demand for our product increasing, like the demand for cell phones, for example. And we might compare that, say, with the demand for home phones. So time is the predictor here, or in this case that's what we're using. Okay, so with that as a background, let's go ahead then and move into sort of the fundamentals of this approach. Now the first thing we need to do is sum up some columns here. So we're going to do that by first summing up column 1. Column X. So that's this column here. And all we did here is add 1 plus 2 plus 3 plus 4, etc., etc. And this all the way up to 10 ought to add up to 55. So we know then that the sum of X, noted right down here, is going to equal 55. So what we want to do then is compute the average of X. So we take the sum of X, which is 55, and we divide it then by N. So what I've done here then is just write down that we've got the sum of N here in the numerator, 55, we're divided by 10, and that's going to be 5.5. Now similarly, we do the sum of Y, which is, again, the sum of this column here, essentially 12 plus 17 plus 20 plus 19, etc., all the way down. We should get 248, and then we'll compute that as the sum of Y, which is going to be Y bar is 248, of course, divided by 10, which is 24.8. Now we move on, and we're going to calculate then this next column over here, which is called X squared. So we have to create the sum of X squared column, because we need this in order to do our calculation. So we essentially go right up here and we just do 1 squared, and that's going to be 1, and 2 squared, which is 4, and 3 squared, which is 9, etc. And then we sum all the way down, and you can see I already did this for you, so it's 385. So we'll just make a note here that the sum of X squared is going to be 385. And in a similar fashion, we calculate the sum of xy, which we can see there is 1593, but let me just show you how I got it. I just made a couple notes here. So here we are essentially taking 1, which is the time period, times the actual, we get 12. Here we have the time period times the actual, we get 34, etc. This would be 3 times 20, which would equal 60. And we do that all the way down, and when we sum that down, we end up with this 1593. So we know now that the sum of xy is 1593. And let's go ahead then and just quickly highlight this. As you can see, I have done here, and now we're going to go on and use these numbers that we just created and highlighted to create our slope. So notice right there, we've got this formula, the slope formula. So now our next task here is to calculate the slope. So what you see in front of you there, I've tried to highlight it, hopefully it's not too confusing, is this formula we use for slope right here. So we're going to just plug in the numbers, really, is all we need to do. So slope, which we annotate as b, I'm going to put a line right here so we don't get confused, is going to equal the sum of xy, which we know is right here, the sum of xy. So let's go ahead, we'll put 1593 minus n, so that's the number of observations, and in our case it's 10, so we'll put 10 in here, times x bar and y bar. So remember we calculated those initially as 5.5 and 24.8. So we'll add those in. And then we're going to divide by the sum of x squared, which we so carefully calculated as 385. So we got 385. And then we're going to do minus, we're going to open up our parentheses again, 10 times x bar squared. So that's not the sum of x squared, it's x bar squared. So it's 10 times 5.5 squared. So we'll close up our final parentheses there. And then we're going to put those numbers in our calculator and go ahead and come up with what's going to be the slope. And now I'm going to go ahead and do this for you on a calculator, just because I have seen so many errors made calculating this formula on a calculator that it's just worth it to go ahead and do it with you on a calculator. So I have taken the time here to put this in my DI-84 calculator made on my iPad, so you can see how critical all these parentheses and everything is. If you don't follow the order of operations, you won't get the right answer, and it will really frustrate you. So you notice here I've got all these different parentheses. Well, I have that because otherwise your calculator will dutifully calculate you an answer, but it won't be the right thing. So you ought to end up with a 2.7757. So if we go with our rounding to 3 decimals, it would be 2.776. So let's use that and move on. So we've got our slope there indicated in green. Now the next thing we need to do is calculate the intercept. So once we get the slope done, it's pretty much downhill from here. That's the hardest one. But the intercept, follow the same principles. You just use the formula right here that I've got written out for you. And the intercept we annotated with A. And so we're just going to say y bar, which we know of course is 24.8, minus our slope, which we know is 2.776, times x bar, which we know to be 5.5. Again, we'll go ahead and put that in our calculator, and we should get about 9.532. Now, pause for a minute here and let's take a look back up at those numbers. We see that our first actual value is 12 with a intercept of 9.532, a first value of 12 makes some sense, especially when we consider the slope is 2.66. So let me show you how that works in the equation here where we calculate the actual predicted value. But that does make some sense, right? Because that's at x equals 0, right? That's the intercept. So, okay, that makes some sense. If we would have calculated this and gotten 900 or negative 12, that wouldn't really make any sense because each period our demand is increasing by 2.776. That's what our slope tells us. So certainly the intercept when x is 0 ought to be, around 9 or 10, or something like that. So now we're going to go ahead and calculate the predicted value using the slope and the intercept that we have just computed. 9.532 plus the slope of 2.776. We're going to multiply it by 1 because 1 is the time period right there. And when we do that, we're going to get 12.308, which is what we have computed to be the predicted forecast for period 1. So we would say the forecast for period 1 is 12.308. And then we'll move on to the linear trend forecast for period 2, or we call it sometimes y hat, because you see this little picture here looks like y hat. We're going to do the same thing, 9.532 plus 2.776 times 2, and that's going to give 15.084, and then we're going to go to the next period and we're going to replace it with 3, and we're going to get 17.860. Now you probably know this, but on a TI-84 it does make it a little bit easier because you can just re-enter the equation. So let me just show you quickly how to do that. So here I am with my calculator. I got in my period 2 there, 9.532 plus 2.776 times 2. And now I want to do period 3, so I just press, you can do that by pressing right here, the second button, and then enter down here at the bottom. So we're going to hold the second and enter. So I press second and enter, and voila, there it is again. So now I'm just going to use the arrow keys, these ones here, to go back over there to where the 2 is and replace that with 3, and then just hit enter, and it's going to give me 17.860, which is very convenient. And if we wanted to say do it for period, I don't know, 8, we just do second, enter, and then let's switch it from 3 to 8. And there we have 31.74. So we'll go ahead now and enter that in. You can go ahead and enter those numbers into your worksheet because you're going to want to fill it out all the way down. And so I'm going to switch over to my worksheet. I will fill it all in, so that you might want to pause here and go ahead and calculate it on your own, and then you can check the worksheet. So here is a great place for a pause. So there we have the linear trend forecast. This is actually the forecast. All of the other stuff over there to the left of what I'm drawing is all necessary to create the forecast, but the actual forecast are these numbers here. So if I was to ask you on a test, what is the linear trend forecast for period 7, your answer would be right here, 28.964. If I was to ask you on a test, what's the linear trend forecast for period 72, well then, all you would need to do is rewrite the formula, replacing the t, in this case, we have the 5 there, with 72, and you would have a number. So the linear trend is a little bit of a pain at the beginning because you have to calculate the slope and all of those things, but once you've got it, it's pretty easy to use. Now, let's just quickly do the MAD. It's just the same as all the other ones we've already done, so there's not a lot to show, but I'll just do a couple of calculations here just so you know. And that is going to be right over here, and we're always going to use the same formula for the MAD, the mean absolute deviation. This is how much does our forecast differ from our actual. So you can see I went ahead and just calculated these for you. So we've got the first one where we have the actual, which is 12 minus 12.0 0.308, and then we've got 17 minus 15.084, and then 20 minus 17.860. So you have to calculate these individual numbers all the way down. And then at the bottom here, what you're going to want to do is sum all of these different numbers. So you'll take 0.308 plus 1.916 plus 2.14, etc., and add them down. Now, one thing I just want to note to you is, notice here in the first one, for example, you would really get a negative number, right, if you took 12 minus 12.308, but you notice I have a positive number there. That's because, remember, it's the absolute value. That's what these things do. So we just take the absolute difference. Then we're going to sum it down, and we'll divide by n, and that's going to give us our average error, essentially. So go ahead then and calculate that, and then you can check your answer back on here. So the sum of the MAD is 21.744, and then we're going to take that and divide it by n, because that's the number of observations that we have, so we just calculate that quickly. So the sum of the mean forecast error, so the sum of the mean absolute deviation is 21.744, and we're going to divide that by n to get the MAD, or the absolute mean deviation, and that's going to be 2.174. So when we compare this to some of the other forecasting methods, it's pretty good. So a couple of important takeaways here is that we have to sum these numbers down, all the way down. I don't have them all written in there, but we sum them all the way down and we divide by 10, and that's how we got that 2.174. And this number here tells us how good our forecast is. So our average deviation from the forecast is 2.174, so that's a pretty darn good forecast model. It's pretty close, where that forecast is very close to the actual. So we say this is a pretty good method. Now, when we look below and we say, what is the forecast for period f of 15? Well, then we're just going to do the same thing we had done before, where we have y hat of 15 is going to equal our intercept, which is 9.3532, plus our slope, which we know is 2.776, multiplied by 15, and that's going to give us 396.912. If we then turn our attention to the next question, which is what is the forecast error, or the MAD? Well, that's what I was just going over above, where we summed the numbers down and we determined that the MAD was relatively low. So let's take a look at that. 2.174, meaning this is a good forecast or accurate model. And which method is better? Well, we use the forecast error, and the forecast error that is the lowest or the closest to 0 tells us which model is the best. Now I'm going to end this video, and I'm going to make another one to show you how to do this using Excel. It's much less tedious and a little quicker calculation. So I hope it was useful. Bye.